Hello again, it is Mrs. Avila back now with SA4, making inferences from sample surveys. Same as always, if you don't already have the notes available, please pause the video, go ahead and get access to those, or get out a sheet of binder paper so that you can take some notes of your own. All right, we have 3 objectives today. We're going to calculate statistics from data to estimate parameters, make inferences from sample surveys, and construct intervals to estimate a population proportion. All right, so just before we jump into it, I want to talk about the fact that there are actually a couple different types of statistics. We talked about in SA3 what a statistic is, and that you use statistics to learn about populations oftentimes, or at least estimate things about populations. But I do want to be a little bit more specific here with the fact that the study of statistics has 2 major branches. It's referred to as descriptive statistics and inferential statistics. Now, descriptive statistics specifically involves the organization, summation, and display of data. Okay, so all those graphs that you've constructed, the numerical summaries you've come about, and then describing what you see in all of that information, that's descriptive statistics. Inferential statistics is using a sample to then draw conclusions about a population. This is kind of the entire point behind why we collect statistics. Now, you can use statistics to make reasonable predictions, or referred to as inferences, about an entire population when the sample is representative of the population. If your sample doesn't represent your population, it doesn't make sense to then use it to draw conclusions about that group, the larger group that you refer to as your population. All right, so here's an example about how we can use a sample data set to try and estimate something about the population. This example, it says the numbers of friends from a random sample of 40 teen users of a social networking website are shown in the table below. So these are 40 teens and the number of friends that they have on this particular social networking site. It says estimate the population mean mu. The population mean with the symbol mu is the true average number of friends that all teens have on this social networking website. Clearly, we don't have all the teens' information. All we have is 40 of them. So what we can do is we can find the sample mean instead of the population mean. So I can take the sample of 40 friends, I can add up, or 40 teens, I can add up the total number of friends that they have, divide by 40. That's how you find an average. And when I do that, I get an average of 299.15. Now, that probably is not the perfect average number of friends that all teens have on this social networking site, but it is my best estimate as to what I think the population mean might be somewhere around. So I could say the mean number of friends for all teen users of this website is about 299. I don't want to say that it is 299, but I can say that it's probably approximately around there. I can also do this with proportions. Same scenario. This one says estimate the population proportion, and I want to estimate the population proportion specifically for what percent of teen users have more than 400 friends on this site. So there are 40 measurements total in the sample. If I scan through my data, it looks like there's only 2 values. There's one at 410 and one at 445, only 2 values, 2 teens out of all 40 that in particular had more than 400 friends. So I can find the sample proportion, 2 out of the 40 gives me 0.05, and I can use that to estimate. So the proportion of all teen users on this website with more than 400 friends, that should say is about 5%. Go ahead and try the you try, and then feel free to check the notes key posted in the agenda to check your answer. All right, we're going to move on to something called sampling variability. Sampling variability talks about how from sample to sample, you will basically get slightly different answers, and that's okay. Okay, so when trying to learn about Granada High School student opinions regarding whether the school should use bells or no bells to indicate the start and end of periods throughout the day, which sample size would likely provide a better estimate for the true proportion? Sample size of 10, 100, or 1,000? What do you think? Does the sample size really matter? Yes, it does. The larger sample sizes typically produce more accurate estimates. Now, that doesn't guarantee it, but if you do have more people from your population in your sample, assuming that sample was taken through appropriate methods, it'll probably yield more accurate results. Not every random sample results in the same estimate of the population parameter. There will be some sampling variability. Sampling variability is the natural variation that occurs from taking different samples. If I ask a different group of 20 students the same question as a new group of 20 students, you're probably going to get slightly different results, and that's okay. All right. So, not only will a larger sample typically help yield more accurate results, but by taking larger samples, you can actually reduce the impact of sampling variability. All right, let's look at this. It says, making inferences from sample surveys. A student newspaper wants to predict the winner of a city's mayor election. 2 candidates, A and B, are running for office. 8 staff members conduct surveys of randomly selected residents. The residents are asked if they will vote for candidate A. And this says, based on the results of the first 2 sample surveys, do you think candidate A will win the election? Explain. Well, if there's only 2 people running, whoever ends up with a majority, meaning more than 50%, they're going to take home the W. So, looking at these 2 samples that have been taken, a sample size of 5 and a sample size of 12, it's not looking too good for this candidate, right? We got 40% and 33.3%, both much lower than 50% mark that they need to get to at least tie, ideally more to win. So I'd say no. With only 2 candidates, one would need over 50% to win, and the first 2 surveys show fewer than 50% are planning to vote for candidate A. This, however, says, based on the results in the table now, do you think candidate A will win the election? Well, if you notice a more complete table presented here, the sample size is increasing. Started out with a sample of 5, not many people, and they finally ended up doing a survey with 200 people. And as you notice the sample size getting larger and larger, you start to notice this percentage of people that are planning to vote for candidate A increasing. So what I can say now, however, is that yes, at this point, I do feel like candidate A might win. As the sample size increases, the estimated percent voting for candidate A gets closer to 59%. Since that's over 50%, I can feel more confident in candidate A winning. The larger the sample, typically the more accurate the measurement. So I'd want to look at those larger samples as my indication about candidate A winning or losing. Go ahead and try this next problem. Again, feel free to check the key to verify your result. Next, we want to talk about intervals to estimate. Now that we've established that the statistic we collect from a sample will likely not be a perfect match to the population parameter, we can start constructing intervals. If we're unable to measure information from the entire population, you can use your sample proportion to estimate the true population proportion. To do this, you can construct an interval around the sample estimate. We can take our sample estimate plus or minus the margin of error. Now, just so we are all on the same page in regards to referencing a sample estimate, a lot of times you will see people use the symbol P with a little hat. Literally, it's called P hat. I wish it had a better name, but that's what we mean by the sample proportion. So why? Well, it's unlikely the sample proportion will be a perfect estimation of the population parameter. It's likely that the sample is probably off a little bit. So we recognize this and create an interval around our estimate and hope that the parameter is at least close enough to our sample to be estimated within the interval. We basically take our P hat and we create a little interval around it in hopes that we had a sample close enough that our parameter is somewhere within that particular range. So how to do this? Well, you need to know something called the margin of error formula. The margin of error formula is plus or minus 1 over square root n. Now, n specifically is just the sample size. Okay, so whatever the sample size is. Notice it's not the population size, it's the sample size. So it's important to know that this is not the population size. This means that if the percent of the sample responding a certain way is p, expressed as a decimal, so like 50% would be 0.5, then the percent of the population who would respond the same way is likely to be between our sample minus and plus that margin of error formula, that 1 over square root of n. So let's see how this works. Here's an example. It says, in the survey of 2,680 people in the US, 911 said that movies are their main source of entertainment. First part says, identify the sample proportion of the survey. So I'm going to go ahead and I'm going to say my p hat, my sample proportion, was the 911 out of the 2,680 people that I surveyed. That would be 0.3399. I could also say that that's about 0.34, or I could say 34%. That's my sample proportion. So now, what's the margin of error? The margin of error is plus or minus 1 over square root of n. In this case, my n being my sample size is the 2,680. Notice it's not just the 911. 911 are the ones that specifically answered about movies being their main source of entertainment, but the sample is all people or things that information was collected from. So I go ahead and I do plus or minus. I'm going to get 0.0193. So I could say that's about plus or minus 1.93%. Give an interval that is likely to contain the exact percent of all people who use movies as their main source of entertainment. I'm going to suggest that you use your decimal answers when you go ahead and try to calculate your interval. You can use your percentages, but you just need to be consistent and use the percentages of both measurements. So I'm going to go ahead and I'm going to say my sample, which was the 0.34, plus or minus the margin of error, which was 0.0193. If I do the plus and the minus version of that, if I do 0.34 minus 0.0193, that's going to get me about 0.3207. If I do the exact same thing, but if I do the plus version of it, I'm going to get 0.3593. So collectively, I could say my interval is between 0.3207 to 0.3593. I could write the same thing as percentages. Either way, I can say that I'm pretty sure that the true proportion of people in the US that say movies are their main source of entertainment is somewhere between 32.07% and 35.93%. Go ahead and try this U-try. Keeping in mind, remember, n is the sample size, not just the people that answer a particular way. Try this U-try and then feel free to reference the key posted in the agenda to double check your work.